Hello everyone, welcome to another learning session. Today we are going to learn about cloud computing. Tell me one thing, how many of you are new to cloud? Tell me one more thing, how many of you are new to IT? In this session, I will start by explaining about cloud computing with the assumption that you are all new to cloud and IT. Then we will look into the three cloud deployment models, namely public cloud, private cloud, and hybrid cloud, along with some real-world examples that you can relate to. After that, we will learn about the cloud abstractions and the shared responsibility model. Post that, we will see some of the benefits of cloud computing. Finally, we will go through some questions to check your understanding of cloud computing based on what you have learned today. So tell me, are you excited to start learning about cloud computing? Then let us get started. I am Hartin Kanugutotu, a hands-on cloud architect and an author. I have worked with many MNCs over the years, developing, designing, and architecting cloud-native apps on both AWS and Azure clouds. Though I have taken many certifications related to programming, DevOps, and cloud, what you see here are some of the most important achievements with respect to my cloud journey. On AWS side, I have authored few internationally published books, and one of them got the award of Best Cloud Computing Books of All Time. On Azure side, I have taken all of the expert certifications and is also a Microsoft certified trainer. You can read more about me from hartin.github.io, which is a GitHub Pages-based website I had created as part of the JIT 101 session. I have talked about me, not to say that I am special or great, but to let you know that I am capable of teaching you cloud and also mentoring you on your multi-cloud journey or even a journey specific to either AWS or Azure cloud. Quote of the day. I generally start a new course or learning program with this quote as it stresses the importance of continuous learning. The person who stops studying merely because he has finished school is forever hopelessly doomed to mediocrity, no matter what may be his calling. The way of success is the way of continuous pursuit of knowledge. This is a quote from the book Think and Grow Rich by Napoleon Hill. With the corona pandemic, we all learned that layoffs can happen to anyone in IT anytime. You are never safe in IT if you don't upskill yourself consistently and stay ahead of your competition. Don't wait for something bad to happen, always be prepared for whatever may happen. If you are well prepared, you won't find it very difficult to get other opportunities, and your current employer may itself try to retain you with a better pay. Road to cloud. In this section, we will look into some important terms and concepts that can help you understand cloud computing better. What is a computer? A computer is a machine that computes something, and computation is the process of carrying out sequences of arithmetic or logical operations automatically, such as executing programs. A computer system is a computer with everything needed for its full operation, such as the hardware, operating system, and any peripheral equipment needed, such as keyboard, mouse, etc. Modern computers comes in various models and sizes, such as regular desktop computers, laptops, and handheld devices such as cell phones, etc. 5 most important parts of a computer. 1. Central Processing Unit or CPU. CPU carries out the computations like executing programs. CPU is a microprocessor or a group of microprocessors called cores put as a single unit to support parallel processing. 2. Graphics Processing Unit or GPU. GPU is used as a co-processor to enhance the performance of the CPU. GPU is designed for parallel processing and is used in applications including graphics, gaming, video rendering, and even in creative production and artificial intelligence. 3. Random Access Memory or RAM. RAM, also referred to as the main memory, is the volatile memory of a computer, and the data is lost if we turn off the computer. RAM stores the application programs, operating system, and the data that is currently used for faster processing. 4. Storage. Data can be stored permanently on a solid-state drive or a regular hard disk, so that even if you turn off the computer, the data stored in that disk drive will be available. 5. Motherboard. Motherboard is a circuit board that connects all other components such as CPU, GPU, RAM, storage drives, peripheral components such as keyboards or mouse, sound cards, interface cards, network cards, video cards, and cards for extra USB slots, etc. Now we will look into the brief history of computing. Bare metal refers to a machine which does not have any operating system, just the hardware. And the next important phase in the history of computing was server virtualization. With server virtualization, one host machine can now have multiple virtual machines. This is made possible by using a software called as hypervisor. We will see hypervisors in detail in the Containers 101 session. Server virtualization is one of the core technologies that make cloud computing possible. You cannot expect your cloud provider to provide one dedicated machine to everybody and then still let them save costs, right? One of the primary reasons why people use cloud is saving costs. And one of the primary technologies that cloud providers use to save costs is server virtualization. Not everybody will be using their machine always, right? So they'll be sharing a single physical host machine through virtual machines so that multiple people can make use of that single physical host machine. So if you are not using resources such as compute, somebody else can make use of it. And if you just stop that virtual machine, you will not be charged. The next important phase in the history of computing was containers. Containers are lightweight alternatives to virtual machines, and they can encapsulate an application as well as its dependencies and make the application portable from one platform to another or one environment to another. Containers helps development teams on efficient application development using architectural patterns such as microservices, and containers also help cloud providers in implementing advanced cloud abstractions like serverless computing. The next important term that you need to understand before learning cloud computing is a data center. A data center is a building or a group of buildings with many computer systems and associated components such as telecommunications and storage systems. There are many computers sitting there. Data centers abstract the actual physical hosting environment and allows customers to store and share applications and data, host websites, etc. Data centers have their roots in the huge computer rooms of 1940s and is even used today, even by the cloud providers. You can learn more about containers, virtualization, and concepts like serverless or microservices from the Containers 101 session. Getting started with cloud computing. In the previous section, we looked into some basic terms and concepts that can be helpful in understanding cloud computing. We will be again seeing data centers today as well as in future cloud sessions. If you are new to containers, I recommend watching the Containers 101 and even the Kubernetes 101 sessions. If you are new to IT and find it difficult to understand the things we discussed about computers, I recommend you spend some time in reading about them from the internet. And if you have further doubts, just ask in our study group. So what is this cloud computing? Cloud computing is the on-demand and automated delivery of computer services and other IT services over a network. So there are some key terms here, right? On-demand, computer resources, IT services, network. Let us see what each of them are. On-demand means that you can get the computer resources and the IT services offered by a cloud computing platform whenever you need it through a programmatic and automatic approach without any manual effort from anyone. Programmatic and automatic approach generally means using APIs. So what are these APIs? API stands for Application Programming Interface and is a type of software interface that allows two or more computer programs to communicate with each other. REST API is a popular API that is used by many web services, including popular cloud computing services. How many of you know what a web service is? How many of you know the difference between a web service and a web application? A web application is developed for use by humans and hence the look and feel is important. But a web service is developed for two computer systems to communicate with each other and hence the look and feel is not important, only data and format is important. Before REST APIs, there was something called as SOAP that most systems used, but it is not used much anymore. If you are new to these terms, you may attend the systems design discussions or just read about them from the internet. The more you know about systems and how they interact, the better you will understand all the advanced things that we will discuss in our future cloud sessions. Now let us see what do you mean by computer resources. Computer resources provided by a cloud computing platform could be any form of compute, storage, and networking, such as virtual machines, databases, virtual networks, etc. And the IT services could be any online service, such as a data analytics service, security service, etc. What do you mean by the network? Network can be the internet or even a private network depending on the cloud deployment model. So what do you mean by a cloud deployment model? We have three cloud deployment models: public cloud, private cloud, and hybrid cloud. We will now try to understand public cloud, private cloud, and hybrid cloud through some examples that we can relate to. Answer this question. What will you do in the below situation? You are new to a city as a fresher and you need a house to stay. You don't know if your job location will change or not. Will you buy a house or rent a house? The most logical answer is rent a house. This is like a public cloud where you can rent computing resources and IT services with a little or less upfront investment and has primarily only the monthly or yearly payments. Here, the upfront investment is generally called as capital expenditure or CapEx, and the monthly or yearly expenses are generally called as operational expenditure or OpEx. So, what is public cloud? In a public cloud, a user uses resources from a cloud provider's data center. In on-premises, we were using resources from our own data centers, right? Or a data center that was dedicated to us. A public cloud supports the pay-as-you-go pricing model. What do you mean by a pay-as-you-go pricing model? It means that you only pay for the time you use a service. For example, you use a service for 1 hour and then stop using it. You will be charged only for that 1 hour. With on-premises, was this possible? No, right? You have already purchased servers in on-premises, but on a public cloud, you are just renting it as a service whenever you need it and pay only for the time you use that service. Now tell me one thing. Imagine you start a virtual machine, you use it for an hour, and then you stop it, but do not delete it. Will you be charged for anything? Yes or no? The answer is actually no and yes. Let me explain. As we briefly discussed earlier, with server virtualization techniques, one physical host machine can now have multiple virtual machines. A stock virtual machine won't need any of the compute from the physical host machine, right? When I say compute, I'm referring to the CPU time, GPU time, and even the associated RAM usage. We had discussed about the parts of a computer, right? CPU, GPU, RAM, disk, motherboard, etc. With cloud, motherboard is completely abstracted away and the rest is virtualized and given to you. Out of these, CPU, GPU, or RAM is needed only when you actually run your VM. But can we say the same for the storage disk? Virtual machines are similar to other machines, right? With an operating system and even its data. When you stop virtual machines, you are no more using CPU, GPU, RAM, etc., but you are still using the storage in the form of disk. Therefore, when you stop a virtual machine, you are not charged for compute, but you are charged for the storage. This is because, unlike compute that cloud provider can allocate to someone when you are not using it, storage cannot be allocated to someone else because your data is still there. However, in today's world, storage cost is much lesser compared to the compute cost. Major cost of your virtual machines is definitely going to be compute, and you are saving on it on cloud. And if you don't need that virtual machine at all, you can always delete it and stop getting charged for the storage also. The next point about public cloud is that it replaces upfront capital expenditure with operational expenditure. What does it mean? It means that you can now start a project or start a startup with little or less initial investment. Without the cloud, if someone wanted to start a startup that required powerful machines, they have to purchase it or lease it. What if the startup idea does not work? What will they do with the expensive hardware? You know very well the resale cost of a computer hardware will be always lesser than what they bought, right? It is not like real estate that goes up with time. Even real estate also goes down with time at times. The startup could even go out of business and they might not even think about doing any innovations again. And what if they realize they need different kind of machines? Selling and buying another set of machines will always result in huge losses, right? But with cloud, you can just stop all servers and start new ones with the desired type you want. Cloud is hence very good for changes similar to the agile development principles that we had learned in our agile and lean for DevOps session. Agility is one of the most important benefits of cloud, as we will see in the cloud benefits section later today. The next point is, with a public cloud, you do not have to worry about hardware maintenance or hardware security, as everything physical is taken care by your cloud provider. You can also benefit from the experience and purchasing power of a public cloud provider. Imagine that you are going to a shop and buying a computer for $100. But what if you buy 50 machines, you will get a discount, right? What if you buy 100 machines, you'll get a bigger discount, right? What if you buy hundreds and thousands of machines, you should get a lot of discounts, right? But as an individual, you cannot buy hundreds and thousands of machines, right? But for a cloud provider, they can do it. They have that purchasing power. Assume that your cloud provider gets machines for $50 and you are getting it for $100. And even if the cloud provider gives to you for $75, it is a win-win for both of you, right? But as we discussed in the server virtualization part, the cloud provider won't have to give you that full machine itself, right? A single physical host machine can have multiple virtual machines through server virtualization, right? So you are still saving on top of that discount that your cloud provider was getting for that hardware. So public cloud has a lot of benefits with respect to cost. These are some of the popular public cloud providers: AWS or Amazon Web Services, Azure Cloud, GCP or Google Cloud Platform, IBM Cloud, Oracle Cloud, Alibaba Cloud, etc. Let us try to answer another question. What will you do in the below situation? You are staying in big mansion with a lot of extended family members. Due to lack of time, you are finding it difficult to maintain the mansion efficiently, do utility payments on time, and even do proper resource allocation among family members and relatives. What will you do? Most logical answer is contract someone like a manager to manage everything, like coordinating with the staff, making payments, and even do proper resource allocation among people staying in that mansion, etc. etc. Here, the mansion could be your own or even leased. This is like a private cloud where we use specialized software to manage our on-site data center or even a third-party data center that is dedicated to our organization. With an on-site data center, there is definitely more capital expenditure compared to the public cloud where there is little or less capital expenditure. So what is a private cloud? It is a cloud that is used by a single entity. A private cloud brings technology of public cloud to on-premises. A private cloud can be hosted from our on-site data center or a third-party data center dedicated to us. A private cloud may use a software stack such as Azure Stack, AWS Outposts, VMware SDDC solutions, etc. And as you know, a private cloud comes with greater cost compared to public cloud in the form of more capital expenditure. Private cloud may be confusing to understand for few as different vendors may define it differently. Let me ask you a question. We saw data centers in the beginning of the session, right? Are private clouds same as traditional data centers? Private clouds are not same as traditional data centers. Private clouds add features to traditional data centers such as on-demand and automated provisioning of computer resources using specialized software. So traditional data centers without on-demand and automatic provisioning software was like that mansion without a manager. But private clouds add that management feature to traditional data centers. One more question to help you understand private clouds better. Is SDDC same as private cloud? So what is this SDDC? SDDC stands for Software Defined Data Center and is not same as a public, private or hybrid cloud, but we can use SDDC solutions to run public, private and even hybrid clouds. SDDC is a virtual data center concept where the components of infrastructure such as networking, storage, compute, security, etc. are virtualized and automated so that they can all be delivered as a service. SDDC solutions abstract deployment, operation, provisioning, and configuration from the hardware so that we are not tied up to the underlying hardware technology. Let me ask you one more question. What will you do in the below situation? If you are settled in a city with an owned house and you have some extended family members coming for some time, but you don't know how long they will be staying with you, what will you do? The most logical answer is you rent a house along with the existing house. This is like a hybrid cloud where you have both private cloud and public cloud. So what is a hybrid cloud? Hybrid cloud is a combination of public and private clouds. Part of services may run on private cloud and part in public cloud. We may use it to extend private cloud with additional resources or services. A hybrid cloud provides maximum flexibility, but at a higher cost than public clouds. Next, we will discuss about the cloud abstractions or the cloud service models and the shared responsibility model. These are the traditional cloud abstractions or the traditional cloud service models. Infrastructure as a service or IaaS is the first level of abstraction in cloud. Infrastructure as a service abstracts the physical infrastructure layer and exposes computing, storage, and networking as a service. The unit of scale here is operating system. We are responsible for managing the operating system like patching and doing all the things. Examples of infrastructure as a service include virtual machines. Next level of abstraction is platform as a service. With platform as a service, cloud provider takes care of the virtual machine, OS, and even the runtime, and developers are only responsible for the application. Here, unit of scale is application. Examples include managed databases on the cloud, Azure App Services, etc. The next level of abstraction is software as a service. Software as a service is any software that is available on cloud as a service. Here, the unit of scale is software. Examples include email, video streaming services, document sharing services, etc. You may be having a personal email, right? A Gmail or Outlook or something like that. They all come under software as a service. Most of the cloud providers have something called as a shared responsibility model. With an on-premises data center, you are responsible for everything. But with a shared responsibility model on cloud, responsibilities get shared between the cloud provider and the customer. Physical security, power, cooling, and network connectivity are the responsibility of the cloud provider, whereas the customer is responsible for the data and information stored in the cloud and for providing access to only those who need it. As a customer, if you write down your password on your desk and go somewhere, and somebody uses that password to do something malicious, you cannot blame the cloud provider, right? Exact responsibility division depends on the cloud abstractions such as IaaS, PaaS, SaaS, etc. For example, this is a shared responsibility model table. With on-premises, all the responsibilities such as networking, storage, servers, virtualization, operating system, middleware, runtime, data, applications, all of these responsibilities are managed by the customer. With infrastructure as a service, networking, storage, servers, and virtualization are managed by your cloud provider. And rest of the things such as OS, middleware, runtime, data, and applications are managed by the customer. With platform as a service, everything till runtime is managed by the cloud provider, and rest of the things, just data and applications, are managed by the customer. With software as a service, networking, storage, servers, virtualization, OS, middleware, runtime, data, applications, everything is managed by your provider, and you just configure and use that software. Software as a service is primarily for end users, while the other things such as infrastructure as a service and platform as a service are for developers. Whatever software you use as a service, like an email service or a document sharing service, behind the scenes, they may be deployed using an infrastructure as a service, platform as a service, or even serverless. There are also newer cloud service models or abstractions than the traditional ones, such as identity as a service, container as a service, serverless, and within serverless, we have function as a service, no code or low code, etc. Identity as a service or IDaaS is a cloud-based authentication service built and operated by a third-party provider. You don't have to worry about managing your users. You can manage your users using a service online. Most cloud providers have their own IDaaS offerings, and there are also cloud-independent third-party offerings such as the one from Okta. Container as a service or CAS is a cloud-based service that abstracts away underlying container management tasks to make deployments faster and easier. Most cloud providers have their own CAS offerings. Serverless is a cloud abstraction model where you don't have to worry about infrastructure, virtual server, operating system, runtime, software server, or even the application. You can either just deploy the functions directly or use tools that require no code or low code. We have seen platform as a service earlier, right? With platform as a service, we need to still deploy the application, and that application has to be created based on the software server runtime we selected. For example, if you are a Java developer, you may create a Spring Boot based application and deploy on a Tomcat server. But with serverless, you don't have to worry about which server you will deploy, or you don't have to worry about building a Spring Boot application. You just write simple code for the functions you need, and everything else is taken care by your cloud provider. Serverless also means you are charged only for the time your service is actually used. This means that even if we deploy the service, if we don't use it, we don't have to pay for it. Behind the scenes, to process our requests, the cloud provider will start a lightweight server or a container when we make requests. Imagine you have a web service that customers use to do some processing. If you are using a virtual machine, your VM needs to be running always for your customers to reach your service. And if the service is up and running for the whole month, irrespective of whether you have customers using the service or not, you will have to pay for the whole month. But with the serverless approach, if your customer does not use the service, there won't be any charges at all. And if your customer make a request, the provider will start a container or a lightweight server behind the scene and process the request. There could be a very small delay called the call start time as the lightweight server or a container is started. But if your application does not care about it, then you can definitely save a lot. Once the lightweight server or container is started, it will continue to run and process requests without this call start time until the provider sees that no requests have come for a specified period of time, and then the provider will stop the service until a request come again. There are also a lot of options for data storage in cloud. file storage, block storage, object storage, databases such as relational databases and non-relational databases. And even within non-relational databases, you have key value stores, document store, columnar store, and graph database. Most of the cloud providers have support for most of these storage options. And if you don't have a managed service for any of these storage options, you can always set them up in a virtual machine. In cloud, you have complete flexibility, right? You can go with infrastructure as a service for maximum flexibility, and you can go with a platform as a service or serverless for maximum convenience. We will see all of these data storage options either as part of our future cloud sessions or as part of our systems design discussions. Let us see some of the benefits of cloud computing. High availability. High availability is ensuring an agreed level of operational performance, usually uptime, regardless of disruptions or events that may occur. High availability guarantees is generally represented using service level agreements or SLAs. When architecting solutions, we need to consider the SLAs and also factors such as RTO and RPO. So what are these RTO and RPO? RTO stands for Recovery Time Objective and is the goal your organization sets for the maximum length of time it should take to restore normal operations following an outage or data loss. RPO stands for Recovery Point Objective and is your goal for the maximum amount of data the organization can tolerate losing. As an architect, when you architect your applications, you will ask the customers what is RTO and what is RPO. It is always tempting for an architect to go for the highest configurations to provide the maximum availability. But as an architect, you always need to make sure you do a balance between availability as well as cost. More availability means more cost. Sometimes that extra cost may not be needed. Cost is a very important factor that you need to consider as an architect while designing solutions. Scalability and elasticity. Scalability is the capability to adapt and perform well under an increased or expanding workload or scope. For example, your system is able to handle 100 requests per second. And if you are getting 200 requests per second, can your system adapt to it and perform well? Or will your system crash or stop giving services to other customers? Scalability is generally achieved through elasticity. Elasticity is allocation of required resources to meet the current scalability needs, such as the ability of a cloud provider to automatically add or remove systems based on the demand. Vertical versus horizontal scaling. Vertical scaling generally refers to scale up or scale down. So what do you mean by scale up or scale down? Scale up is replacing servers with more capacity ones or increasing the capacity. For example, if you have a computer and you are upgrading your RAM or upgrading your processor, that is scale up. Scale down is decreasing the capacity of servers. For example, you are downgrading the RAM from 16 GB to 8 GB or going from a 4-core processor to 2-core processor. Horizontal scaling generally refers to scale out or scale in. Scale out is adding more servers to share the load. Scale in is removing extra servers that are not needed. In scale out, more servers of similar capacity are added to share the load, and a component such as load balancer is put on top, which will divide the load among all of these servers. Scale in is the opposite. Scale in is removing extra servers that are not needed due to lesser load. Many cloud providers provide automated horizontal scaling based on factors such as CPU usage, memory usage, and is generally referred to as auto scaling. Let me ask you a question. In the previous slide, we talked about auto scaling with respect to horizontal scaling. Why do most cloud providers give auto scaling facility only for horizontal scaling and not for vertical scaling? Vertical scaling refers to changing the system configuration, such as upgrading the CPU or RAM of a machine, which cannot be done automatically when the customer is waiting for a response. With VMs on cloud, this generally means that changing the instance type and may even have to stop the service. Horizontal scaling, on the other hand, is easier to implement for a provider, as the servers of a same type can be added or removed based on demand, and a component such as a load balancer can make sure all available servers receive customer requests making use of some algorithm. Fault tolerance and disaster recovery. Fault tolerance is ensuring that servers or services remain available even if some fail. Disaster recovery is maintaining or quickly resuming mission critical functions after a failure. So what is the difference here? With fault tolerance, your service continues to run even after a failure. But in disaster recovery, a service may be interrupted, but it will recover faster. Fault tolerance is generally implemented within a region with multiple servers or data centers handling load simultaneously. So if one of those servers or data centers go down, other servers or data centers can still continue to serve the request. Disaster recovery is generally implemented across regions and it is done generally as a backup plan. If the primary region fail, the secondary region can come up and there could be some downtime between these two activities, one going down and one coming up. A quick question. We have learned about two terms called high availability and fault tolerance, right? Both of them try to make sure that the system is up and running. So what is the difference between these two? In high availability, performance and uptime in response to increasing demand is considered, while with the fault tolerance, only uptime in response to a failure is considered. Another question, what is preferred, low latency or high latency? And before that, tell me how many of you know what latency is. Low latency is always preferred. Low latency is the ability to access services faster to the internet. Global reach and latency requirements. Global reach means you can easily reach many regions globally for compliance as well as latency requirements. For example, if a country or region is telling that if we want to do business with our people, you have to keep the data within our country or within our region. Without cloud, you'll have to go there, set up a data center, or even rent space in somebody else's data center. With a public cloud infrastructure, you can just select a region and start deploying your applications. Low latency can be achieved by deploying resources in regions closer to the users or even using CDNs. CDN stands for Content Delivery Networks. It can be considered as a cache near to the user. So when one of the users use a service for the first time, the CDNs will cache that data closer to the user. And next time when somebody tries to use it, it will deliver that resource from the cache and not directly from the server. So based on compliance requirements, based on cost analysis and all, you will have to come up with these decisions, whether to have a data center closer to the user or whether to have CDNs to reduce the latency. Security. You can always find a cloud solution that matches your security needs. Some people may need maximum flexibility, while some people may prefer convenience. If you want maximum control of security, infrastructure as a service lets you manage the operating systems and install software, including patches and maintenance. If you want patches and maintenance taken care of automatically, platform as a service or software as a service deployments may be the best cloud strategies for you. The cloud providers are typically well suited to handle things like distributed denial of service attacks. What do you mean by distributed denial of service attacks? Before that, what do you mean by denial of service attacks? Assume that your application can handle 100 requests per second. And imagine that an attacker sends you 200 requests per second or 1000 requests per second. What will happen? Your system may not be able to handle it and it could crash. It could lead to not providing service to the actual intended users. So the service is denied for those users. But these days, many services has inbuilt features to check whether a single IP is sending you more than X requests per second. And it is very easy to prevent denial of service attacks. So what did the hackers do? So they started sending all these 200 or 500 or 1000 requests from different IPs. This is called as distributed denial of service. And most of the cloud providers today are well suited to handle these things, making use of machine learning, artificial intelligence, etc. The cloud providers also generally provide recommendations or templates or blueprints for governance and compliance and help ensure that all deployed resources meet regulatory compliance. Predictive cost. Many cloud providers provide tools for predicting or forecasting the cost of the cloud spends. Pricing calculators can be used to get an estimate of potential cloud spends. Total cost of ownership calculators can be used to estimate the cost savings through cloud migrations. We can also monitor resources in real time and use data analytics to ensure that we are using them in the most efficient way and adjust our resource usage as needed. Agility. Agility is the ability to move quickly and easily. Cloud allows us to move quickly and easily than on-premises with respect to many features such as high availability, scalability, elasticity, fault tolerance, disaster recovery, global reach, latency, security, predictive cost, etc. It doesn't mean that all of the above features are available only to cloud, but setting up these things efficiently in on-premises require a lot of additional efforts and costs that we could have easily invested in our application development. In most cases, it means more hardware that will be used only when needed. But cloud services are provisioned on demand and need to pay only for the time when we actually use them. Let us consider an example of an e-commerce website like Amazon, Flipkart, Walmart, etc. Imagine that you need 100 servers for your regular operation, but on a sale day like a Black Friday, you need 500 servers. In a public cloud, you can scale up to 500 servers just for the sale day, and you need to pay for those extra 400 servers only for that sale day. But with on-premises, you need to purchase or lease additional 400 servers, which will be only used during the sale days. This is one of the biggest advantages of public cloud platform with respect to cost savings. And this is a summary of the cloud benefits we discussed: high availability, scalability, elasticity, fault tolerance, disaster recovery, global reach, low latency, security and compliance, predictive cost, and agility. As mentioned earlier, most of these are not specific to cloud, but we can achieve most of these easier and faster on a cloud platform. Questions to check your understanding. Let us now go through some questions to check your understanding of cloud computing based on what you have learned today. Question 1. Which expenditure model is used with the pay-as-you-go subscription models? A. Operational, B. Elastic, C. Capital, D. Scalable. Answer is operational. Operational expenditure or OPEX is the ongoing cost including annual cost. Capital expenditure is the initial investment such as buying fixed assets. Pay-as-you-go means operational. You pay for the usage, you don't have to pay upfront as a initial investment cost. Question 2. A company can extend a private cloud by adding its own physical servers to the public cloud. True or false? Answer, false. You don't have access to anything physical with the public cloud, right? Everything physical is managed by your cloud provider. Question 3. A company plans to migrate their on-premises servers to cloud. Which of the following administrative responsibilities would be reduced by this move? A. Ensuring failed server hardware is replaced. B. Taking regular backups of application data. C. Managing the physical security of the servers. D. Ensuring the operating systems are patched on a regular basis. Answer, ensuring a failed server hardware is replaced, managing the physical security of the servers. Everything physical or hardware is now managed by your cloud provider in a public cloud. You don't have to worry about it anymore. Which of these cloud deployment models provide a choice to use on-premises or cloud-based resources? A. Hybrid cloud. B. Private cloud. C. Public cloud. Answer is A. Hybrid cloud. In hybrid models, we have both public and private cloud and provides maximum flexibility. Question 5. Replacing servers with more capacity ones or increasing its capacity can be called as A. Scaling out, B. Scaling up, C. Scaling down, D. Scaling in, E. Horizontal scaling, F. Vertical scaling. You can choose two options: scaling up and vertical scaling. Replacing servers with more capacity ones is scaling up. Reducing the capacity is scaling down. Both scaling up and scaling down are referred to as vertical scaling. Question 6. Adding more servers and processing in parallel can be called as, choose two options: A. Scaling out, B. Scaling up, C. Scaling down, D. Scaling in, E. Horizontal scaling, F. Vertical scaling. Adding more servers and processing in parallel is called as scaling out or horizontal scaling. Both scaling out and scaling in are called as horizontal scaling, right? Question 7. Which of these can be part of auto scaling in cloud? Choose three: A. Scaling out, B. Scaling up, C. Scaling down, D scaling in, E horizontal scaling, F vertical scaling. Answer is scaling out, scaling in, and horizontal scaling. We learned, right? Most of the cloud providers provide auto scaling only for horizontal scaling. We had seen the reason also within the session. Hope you have learned something new today. As long as you have learned something new, the time of this session was worth for both you and me. It is all about consistency in learning. We have to consistently learn and move forward. As long as we are moving forward, we are making progress towards becoming better software engineers. Never stop learning. That was why I started this session with that quote from Think and Grow Rich about people who stop learning after college. So let us not stop learning. Let us continue to learn and grow together in our study groups. Bye bye for now, and see you all in next class.